Welcome to Krne's YouTube channel. In this video, I will talk about electrolytic capacitors, complete details, working principle, precautions, and limitations. What is electrolytic capacitor? Electrolytic capacitor is a type of capacitor that uses an electrolyte to achieve a higher capacitance than other capacitor types. It is widely used in electronic circuits for filtering, coupling, and energy storage applications. Construction of an electrolytic capacitor. An electrolytic capacitor consists of the following key components. Anode, positive plate, made of aluminum or tantalum. Oxide layer, dielectric, a thin insulating layer of aluminum oxide or tantalum pentoxide. Electrolyte cathode, a liquid, gel, or solid electrolyte that acts as the second electrode. Encapsulation, a cylindrical aluminum or tantalum casing with a rubber seal to prevent leakage. Lead wires and terminals, used to connect the capacitor to a circuit. Types of electrolytic capacitors. There are three main types. Number 1. Aluminum electrolytic capacitors, most common type, used in power supplies, audio circuits, etc. Number 2. Tantalum electrolytic capacitors, more stable and reliable, used in military and medical equipment. Number 3. Niobium electrolytic capacitors, similar to tantalum but with better performance in certain applications. Working principle. An electrolytic capacitor stores electrical energy by accumulating charge on its plates. The working principle is based on electrostatic storage of energy. Charging phase. When a voltage is applied, electrons accumulate on the negative plate, while the positive plate loses electrons. Dielectric formation. The aluminum or tantalum plate forms a very thin oxide layer due to anodization, acting as a dielectric. Electrolyte role. The electrolyte serves as the cathode, allowing high capacitance values because of the very thin dielectric. Discharging phase. When the capacitor is connected to a load, the stored charge flows, providing energy to the circuit. Key characteristics. High capacitance ranges from 1F to several farads. Polarity sensitive, must be connected with correct polarity, plus and terminals. Voltage ratings, typically from 6 volts to 650 volts. Leakage current, small current flow due to electrolyte conduction. Equivalent series resistance, a small resistance affecting capacitor performance. Applications. Power supply filtering, used in AC to DC rectifiers to smooth voltage fluctuations. Coupling and decoupling, allows AC signals to pass while blocking DC in audio and RF circuits. Energy storage, used in flash cameras, UPS systems, and high-power applications. Timing circuits, used in RC timing circuits for delays and pulse generation. Precautions and limitations. Polarity check. Connecting incorrectly can lead to capacitor explosion. Voltage rating. Never exceed the rated voltage. Temperature sensitivity. Higher temperatures can reduce lifespan. Aging effect. Capacitance decreases over time due to electrolyte evaporation. Electrolytic capacitors are essential in electronics for energy storage and filtering applications. Their high capacitance values make them ideal for power supply circuits, but their polarity sensitivity and aging effects must be carefully considered. Comment below the video and let us know which component details you want to see in the next video. If you enjoyed this video as a support to grow my YouTube channel, don't forget to subscribe, like, share, and comment to my video, and you can also get every upcoming update about my new video on my YouTube channel. So don't forget to like those. Thanks for watching.